So welcome to iMath. Today I'm going to answer a common question about the unit circle. So let's draw the unit circle first. And the question is, these are the axes, the y-axis and the x-axis. So as I was saying, the question is, this is the radius P1, OP1, P2, P3 and P4. We use these when extending the definition of trigonometric ratios, so they become trigonometric functions now. The reason many people ask why it's always positive 1 everywhere. Why is it always positive 1? Why is it not negative 1? Because in the negative axis, especially here, especially in this quadrant, in the third quadrant, why is this positive? Why? So today I'm going to answer that question. It's an awesome question to answer. So let's get back to the unit circle. Okay. So first you need to know that something about vectors. So vector is just a physical quantity which has a magnitude and a direction. That direction is shown by an arrow, and the magnitude is proportional to the length of that arrow. Well, this is actually a radial vector. Radial vector. It's not a scalar, it's a vector. And also, when you say, for example, if you take this as positive direction, then this vector would be algebraically called +5 units, and the vector in the opposite direction would be called -5 units. But if you've already specified the direction, the magnitude is just 5. So since here we've already specified the direction of radial vector, it's always just the magnitude that's given. That's just 1 in either direction. Just the magnitude is given. The magnitude is just 1, not -1. Most people just give an answer that it's a circle, it's a radius is always positive. Well, all that is crap. This is the real answer because it's a radial vector. Now vectors can be resolved. That resolving a vector means, for example, if we have a vector, for example, vector v of v magnitude in that direction, so you can resolve it into two vectors, and these are mutually perpendicular vectors. So these vectors, this vector, this vector can be treated, or rather this vector can be treated, independent. The red vector can be treated independently of the blue vector, independently, because they're perpendicular and they don't affect each other if they are perpendicular. So coming back, this is the exact same thing we do here. So exact same thing we do here. We drop a perpendicular. So as we know, this is sine theta and that is cos theta. Watch my last video. Watch the video on trigonometric ratios, radians and unit circle if you don't understand why. But a quick recap, cos theta is perpendicular. Oops, this is cos theta and this is sine theta. Cos theta is just base by hypotenuse. Hypotenuse is 1, so base by 1, which is base. And similarly for sine theta, because sine theta is perpendicular by hypotenuse. and therefore sine. And tan theta is just sine theta by cos theta in all cases. Okay, so now there's a question, and a pretty good question, I must say. And the question is this. So let me just erase this off. And now the question is this. The question. Now they say if this is the unit circle, these are the axes, the y axis and the x axis, the coordinate axes, and that's 0. So they ask a very good question, I must say again. If this was -1, what would happen? Okay, so now let us delve into this question of what would happen if this was -1. So a vector in this direction can be resolved into two vectors like this according to there's also a rectangle rule in this case. See, it forms a rectangle. It should always form a rectangle. For perpendicular ones it will form a rectangle. For others you can even do parallelogram using the parallelogram rule. But I'm not going to talk about mutually perpendicular vectors because they don't affect each other and can be treated independently. So a vector in this direction would have its components, these are also called components, would have its components. So a vector is resolved into two perpendicular rectangular components. So in this case the x-axis component would be cos theta and the y-axis component would be sine theta. But if this was -1, then this would be if you took the triangle here, if you completed the triangle here, then sine theta would become negative in the second quadrant, hypothetical, remember this is hypothetical, and cos theta, which is negative by negative, would become positive, which is not the case because it's just not possible. Because if you have a vector here in +1 direction, then it would be here. But if you have a vector here with -1 direction, this scalar magnitude multiplied by the unit vector in this direction would actually give you a vector in this direction with 1. So in this case the vector would actually become in this direction with 1, and in this direction we know sine theta is positive and cos theta is negative. So it's just not a correct way. Here also if we had -1 here, then this would be equivalent to having a vector here like this, and both would be positive since negative by negative is positive, negative by negative is positive. So we always take the hypotenuse as positive because it's a vector, and 1 is just the magnitude of that vector. Direction is given by the arrowhead and can mean any direction. And if you plot the direction, as the direction increases, for sine for example, you'd get a curve that looks like this. See, at this point of the unit circle it's like that. At this point of the unit circle it's like that. See, this is 90. See, this is 90 degree. At this point of the unit circle it's like that, and at this point it's like that. So there's a good diagram of this on Wikipedia. You should check it out. For more videos like this, For more videos like this, you may visit go to my YouTube channel at let me write that in a good color, green. You may visit me at imath.tk. Just go links directly to my YouTube channel. For physics videos created by me, of course, visit physics.tk. It's a play on the word physics, and then from there click on vibrant videos. Okay, so see you later.